together number 22, and here we go. Let's start with the beginning. Some of you are wondering about the paragraph at the end, and that's totally fine. We'll talk through it. We'll talk through it, and you guys can write down what you think you need. Alternating series estimation theorem. Estimation. Why is it an estimation?
It's not
Because we can only solve exact sums for
geometric
and convergent geometric and
Alternating.
telescoping series. So, listen. If the alternating series, which we know it could be just n, it could be n plus 1, it could be sine of pi, pi over 2n, right? A base of n converges. Well, that makes sense. It wouldn't really have a sum otherwise. Then a truncation error, hold on, wait a minute. On the AP exam, it says that it will grade you correct if your answer is correct to 3 decimal places, rounded or truncated. What's it talking about? If you just cut it off, right? So truncation error. Truncation error. What are we cutting off? Well, hold on. The truncation error, we know that. For the nth partial sum. Okay, so why is there a truncation error? Where are we cutting this infinite sum?
When it's less than a plus 1.
Truncation error. What kind of series is this? I know it's not fully written because it's hard to write it fully, and I just stole it and they just said.
alternating series.
It isn't alternating, but what are the bounds?
N is equal to 1,
2,
0, 2.
2. Starting at 1 and going to or towards
Oh, that's what
infinity.
you meant by
It's
that.
an infinite sum, true?
Yes.
Are we literally adding all the infinite pieces together if we're doing an nth partial sum? No. If, I think this was in one of your homeworks the other day, a 6th partial sum, what would that be? The sum of the first 6. The 50th partial sum would be the sum of the first. We are cutting the infinite sum off. We're truncating it. Instead of the infinite sum, we're only looking at part of it. Does that make sense? Okay, so truncation error, partial sum. That's where the truncation is coming in. So, the truncation error for the nth partial sum, the nth partial sum is less than a sub n plus 1. It's less than the n plus first term, regardless of the alternating sum. Meaning if an alternating series converges, then the error of estimating the sum using n terms is less than the n plus first term. Pause real quick, technically. We should probably put parentheses around the n plus first to make it all nice and appropriate. From this paragraph down below, okay? From this paragraph down below, how can I label all the different pieces to this little formula up here?
S is sum.
Okay, S is sum, what kind of sum? A truncated sum, a partial sum?
Cumulative sum.
Higher sum. The perfect
S
sum.
of n is partial sum. Yeah.
Question, do we know the sum of an alternating series? And the answer is no. We don't know the sum, unless it's geometric, possibly with an R that's negative. That'd be the one exception, but for any general alternating series, we don't know the sum. So the sum is unknown. Does that make sense? The sum, we don't know it. But what can we find?
S of n is a partial sum.
We can find the nth partial sum. What else can we find?
That one.
The n plus first term. Can't we find a term if we need it? If we're taking the 6th partial sum, we can find the 7th term. If we're taking the 10th partial sum, we can find the 11th term. We can find a term. We can find a partial sum, but we can't find the entire sum. So the point isn't plugging in S. The point is thinking of, okay, well, whatever I do find, how far off is it? Hey, who's your R? Keep the paragraph down below, read it.
Remainder.
Remainder. And what's another word for remainder according to the paragraph down below?
Remainder.
Error.
Error. Another name. When you plot the partial sums on a number line, they jump past the sum each time. Wait, why does that make sense? If we were to plot the 6th, the 7th, the 8th, the 9th, why would it be jumping past the actual sum? Think about the alternating nature of a sum. If the terms are decreasing, that's the only time it'll be convergent. If the terms are decreasing, if you add right? What's gonna happen next?
It's gonna come after.
It's gonna subtract,
Yeah.
right?
Yeah.
So you're gonna add, but all of a sudden then you're gonna subtract, and then you're gonna add, and you're gonna subtract, and add, and subtract, and add, and subtract. Somewhere in the middle is the sum. Does that kind of make sense? Okay. The distance it jumps keeps on decreasing because the terms are decreasing, because the limit of the terms is 0. The error, aka the absolute value, do I care if it's above or below? Not really, is less than or equal to the magnitude of the first neglected term. What's this paragraph doing? Putting all of this in even further, broader, not broader, more detailed words. Because what's the first neglected term? The n plus first term, right? The first, when you truncate, who are you neglecting? All these guys. Who's the first one? It's the next one. So all of this is basically just restating what's up there. So you need to write it? Not necessarily. I was just trying to give you some of the theory behind it. I thought it was interesting. The bottom line is you can get an idea of how close you are to the actual sum without ever knowing it. So once again, what part don't we know? And we're not meant to. We're not meant to, in the sense that we're not meant to be able to find it. We're meant to be able to approximate it and say how close it is. And once again, this entire estimation theorem is only good for who? That, yeah, there's no point in this if it diverged, right? Because we wouldn't even be able to, we could approximate the sum, but we definitely couldn't say that it's bounded or stabilizing towards any sort of value. So, if I give you the following, pause, write it down. Pause, write it down. Take the time to read it. I mean, you guys are, you know me fairly well, as far as a teacher, right? Some of you as a person, but as a teacher, why do I make my classes write the directions in our homework?
Because there are stuff in the directions that we don't have to know.
There are crucial things in the directions that are frequently overlooked. And not just necessarily in the stuff that's next to the problem, sometimes in the whole paragraph that's above that happens in pre-calc and in AD and in BC. And it gives you a chance, before having to solve it, to think through word by word what's been given. That doesn't mean we always approach writing them well. But take a second as you're writing. Think through all the words. Think through your past knowledge, even the card that we just laid down. How does it apply? Put those people brains to work.
She's so much called it cute.
Call their brains small.
That's because her brains are cute.
It is actually an asshole.
I'm not sure a big brain necessarily equates to smart one, so I don't think a little brain was really big. So that was perfectly factual.
You're actually your gardener who's sponge space. Really weird person.
That is like fifth grade.
This is a green glass.
Nobody's in kindergarten.
Wait, is it English or is that Tennessee?
Nobody's in kindergarten.
No,
They're sixth graders.
They're sixth graders?
Yeah, I thought they were sixth graders.
I don't think fifth graders is Canada. I don't think it really matters. Okay, how old is SpongeBob?
SpongeBob's an adult.
It's like 100 years old.
Not 100.
SpongeBob? 60 when we started. And he was like 20 years old.
SpongeBob, I think about
He doesn't eat it.
So those are all the SpongeBob.
You put a lower throw box.
Maybe like 1.5-ish. Okay, then add a fifth.
Also, they're talking.
You could add a fifth, at least 1/5. Yes.
Alright, what are some important words that you need to pick out of this thing? Okay, I see a few things. I've heard a few things. First of all, is it helpful that they gave us a convergent?
Alternating series, yes.
That's nice. Could we have proven that? Yeah, but do we need to? No, they told us it was. Cool. Estimate the sum.
Ooh,
First 5 terms.
ooh, that's a spray paint one.
How accurate?
Oh.
That's a great one.
How many terms,
That sucks.
would we need to sum in order for the partial sum to be within? All right, this gets a little bit interesting, right? Let's take it step by step. What's the first thing we need to do?
Estimate the sum.
All right. Estimate the sum. So you define S sub 5. You guys agree?
Yeah.
Cool. How do we do it?
Add them together.
Add them.
1
Get
Right.
a common denominator.
1, 2, 3, 4, 5?
Positive is like.
I guess we get a common denominator for 1. 2 and 3 and 4 and 5. What do we got? 60?
100.
Yeah, 60.
60.
Why would you do that?
It's 60.
Easier to.
Okay. So, I mean, I would just make that 1/2. That makes life a little bit easier. But we could go ahead and do 30 60ths plus 10 60ths minus 15 60ths, right?
Yeah, and then 12.
Plus 12 60ths. Which ends up being 43? No, sorry, I apologize, 37. Right?
Wait, do you know 23 60th?
Well, I did 1 minus a half is a half, so that's why I did 30.
But then 1/3 is 26. Because, yeah, I was confused by 10.
No, thank you, thank you. I don't know what's going on.
So add a 10.
So 47, right?
Yeah.
How did you do this so fast? It's like you had a computer that would do it for you.
Years.
Nice.
Okay, pause, do you agree?
Yes.
Now, that's our fifth partial sum. That's great and all, but that's not all they ask. I'm just doing little A's, B's, and C's, because okay, we did the first step, but then it says how accurate, right? How accurate, what do I know?
Nothing.
Because of endeavor number 22. Because of endeavor number 22.
Yes.
I just found the fifth partial sum of a convergent alternating series, and what do I know about this sum?
That is convergent.
This sum is going to have a remainder or an error that is less than or equal to
Oh, the whole sum.
a sub
And plus 1, so 6.
Cool.
pause. Check. I'm just applying the card. The card says that the error or the remainder of the fifth partial sum to the actual sum is going to be less than or equal to the n plus first term. And what's the n plus first term? Well, I just took the first 5, so the 6th. So couldn't I say that my sum, 47 60ths, and the actual sum, which I don't truly know, is going to have a remainder or an error that is less than or equal to, what's the next term? Technically, it's absolute value, right guys? Sorry, absolute value, he said then?
Yes.
Negative
1/6. No, positive 1/6. The term is a negative 1/6, true.
It's absolute.
But I'm saying that the error is within, I'm just saying the absolute value.
Oh, I thought you didn't know anything because you didn't know those.
So what can I say? I can say that my sum, my fifth partial sum, is accurate. Here's another way of saying that the error is less than or equal to 1/6. It's accurate within, well, what is 1/6?
0.13333333.
Close.
No?
0.1, is it 1/61616?
Oh, is it that?
Or is it 1/6666666?
No, it's like 1/6.
How dirty.
Now, technically, kiddos, I like the less than or equal to 1/6. I like this probably the best. I like this probably the best because it's literally just the forever card.
That's
The
nice.
alternating series remainder theorem. But why did I show it in a decimal?
Because they wanted to.
Part C. Part C says, you know what, we want it accurate to within 0.005.
We're not even. So like decimal order, correct?
If you think about it.
Yeah.
Just change the decimal.
Oh, that's what it
Change the decimal to
I need a sub n plus 1, right, to be less than or equal to 0.005. True or false?
True.
True.
If I can say that my n plus first term is less than or equal to 0.005, then doesn't that mean that my remainder of whatever the nth partial sum is would be within that accuracy?
Yes.
Perfect. So isn't this just an equation I can solve? Because who is, or what is an expression of the n plus first term, and technically the absolute value of the n plus first term? Okay.
That's minus 47.
It's so there.
Why not just 1 over n plus 1?
Oh, that.
Where'd you get her from? Oh, that's for
1 over n is my a sub n, so 1 over n plus 1 is my a sub n plus 1. We take the formula itself for the nth term of the series and just say plug in n plus 1 and let's solve this puppy, guys.
That's nice.
Right? If you want to be super snazzy and not have to stress about the nasty, nasty decimal, couldn't we just make this 5 over 10, 100, 1,000, which would be the same thing as 1 over 5 over 1,000 is 1 over 200, right? Double check me.
You can just say it's 200.
The reason I'm saying this is because this might not be a calculator problem. What?
Then you solve for n?
But this one's not too bad, because isn't it just 200 equals n plus 1?
Yeah.
Yeah.
So n equals 900.
Technically, 200 is less than or equal to,
Z
right?
equals.
What?
And n is
199
or 189.
Yeah, 199.
Why did
Wow.
it switch like that, Miss Stewart?
X.
Oh, I did cross multiplication, so the 200 came up, so he's on this side, and the n plus 1 came up, so he's on that side. And now I'm looking at n himself, so I subtracted, but the greater than needs to be towards the end.
Could you not have just flipped it? Put the inverse on both sides? No?
Oh, you put it in one.
Because if you flip it, the inequalities are different. If it's an equal sign, you can flip, but if it's an inequality, you can't.
So
Just
can you
use-
just say you flip the inequalities?
Yes? I think so. You can say that. Hold on, let me get this, 199. So what does that mean?
So that the 199 term,
199 terms.
At least 189.
Yeah.
I just had a question about rules when solving with greater than or equal to signs.
Yeah.
If there's a negative and we were to I think it was negative, there's a rule where you have to switch signs or something like that? Or
Yeah,
switch
say
the
there was
character?
something where it was like 1 minus n, let's do that.
Uh-huh.
If there was 1 minus n, the 200 would come up, the 1 minus n would come up, I would subtract the 1 and divide by a negative. It's not so much about subtraction, it's about multiplying or dividing by a negative. If you ever have to multiply or divide by a negative, then you flip the sign.
Okay, thank you.
You guys get the idea?
Sweet.
Ready, set, go.
I just forgot it.
Hold on, let me get to the actual series though. That's number 31.
What is easy? Impossible.
Oh, come on, give me a second.
What do you mean?
I can cheat, but I need to go find it.
What's that one?
This is 95, right?
Yes.
I'll write those down.
Go. To be quite honest, I changed it a little bit, but it still works. You're welcome. I made it more fun.
Yay! I like fun.
I should probably make sure I made it the right kind of fun. Hold on.
What's the right kind of fun?
The kind of fun as possible.
The kind of fun that totally matches up with the one in the book in the sense of its signs aren't opposite.
so you can plug in 1. What is sine of plus 2? 2 of pi is 0.
No, one more thousand. Oh, you do like that.
Pause. Thanks, Katrina, for working it out loud, because I don't. There you go. Now go.
Does that matter though? We're not finding the number.
No, it doesn't. Because the other one would be 1, 0, negative 1, 0. Like you would have every
No,
other
it
term
wouldn't
be
be
off.
through because it would be, like, it would have been a negative 1 over 27.
We would have had to rewrite the series in order to think of it as an alternating, because every other one would be 0.
Yeah, asking greater than or equal to 0.00.
There we go. Now it's good.
So what do you well, what's
That's 2.
Is that 1 over 1,000?
Is it just 1 over?
I give up.
Just be 1 over.
And I'm giving up.
Negative 1.
Sine is hard. The 3 part.
I just hate tricks.
Power 2 is negative
Negative
1.
1.
It's negative 1. Yeah.
So it's negative 1, that's the first term.
So it'd be negative 1 all over 1, right?
Yeah, so
Okay, and then plus, and then when you plug in 2, that's just back at pi over 2, sine is positive 1.
it'd be 1.
1 over
You're
8.
so smart. I don't know why.
And then it's going to be minus 1 all over.
That's not what it's at.
27.
Yeah, but it's just
I'm just trying to let people know that this is really just, and I've been telling you out loud, and you're like, and then you freaked out when I actually gave it to you. This is the exact same thing as negative 1 to the n. Same thing.
What?
Okay.
Because sine of 3 pi over 2 is a negative 1. Sine of 5 pi over 2 is a positive 1. Sine of 7 pi over 2 is a negative 1. This is just negative 1, positive 1, negative 1.
I think I'm doing like the AP exam, like the book.
Oh my god. They usually like cosine, because cosine of pi is way easier than sine of pi over 2.
It is 1.
Oh, you got me, oh.
Long story short, it's alternating. Long story short, it's convergent. Okay. Pourquoi? Why is it convergent?
Because it will come down to a certain number.
It's decreasing and
The limit equals
the
0.
limit as n goes to infinity equals 0.
What is 1? What's 0.001 written as a fraction?
Being tenths, hundredths, thousandths, 1 over 1,000.
Oh, cube root of 1,000.
What's the cube root of that? So minus 1.
1,000 is 10
Oh, what
times 10
Yeah.
times 10.
I'm so smart. 9! Right?
What are you guys doing right now?
Nice.
Makes sense.
Are you doing a sub n plus 1 needs to be less than or equal to 1 over 1,000?
Yes, yes.
Could you then plug in and just say, you know what, it's absolute value, I can totally ignore the sign stuff?
Uh-huh.
So 1 over n plus 1 cubed?
what's you flip? Wait, it's 10. Oh,
9.
Cube root both sides, I get 1 over n plus 1 is less than or equal to 1/10. 1,000 is 10 cubed.
Why is it n plus 1?
N plus first term, I have to plug in n plus 1 to the nth term.
Those are nice.
But remember, I get to ignore the whole sign of, because that's just the alternating sign, right? The positive, negative, which is irrelevant when as soon as I put the absolute value. But I multiply up the 10, multiply up the n plus 1, n has to be greater than or equal to.
Where, how did it go from, oh, you took the cube root?
Oh, if it helps, make the 1,000 and 21 cubed on top first.
Yeah, I'm supposed to.
When we do the plus 1, we add it into the, like how for the first cubes we did it.
Yeah, at least not this.
Okay.
And we would go here if we needed to, but we don't.
I like this.
So, at least, extra stupid next. Alright, how are we doing? You okay? Alright. Huh.
Wait, whoa, Steve,
No, there's no directions.
Yeah,
It's a series divergence.
Come on, think through what the directions be.
Find formation, you guys in the afternoon.
Find the, well, you can't find that sum, that doesn't work. Okay, so first, does it converge or diverge? Go. Nah, with a justification, you guys saw me take 1/2 points on that quiz, come on. Converge or diverge? Good question.
See, I'm gonna go with it converges because if you take out that, you're gonna 1 over.
Yes. For convergence with the factorial, at this point, the only option we really have is a comparison
Oh,
test.
direct comparison. So then call just do n squared.
Take the limit.
As far as absolute
Oh, yeah.
and conditional, what if you were just testing for convergence?
So it's
It's convergent because of direct comparison test.
No, if you were just testing for convergence, not conditional, absolute, you could just say, hey, the limit is 0, and the terms are decreasing. Sweet, whew, it converges. All right, the conditional absolute, what would you have to do?
Take the absolute value.
Because the directions say, determine whether the series converges absolutely or conditionally or diverges.
So since absolute.
That means I have a 1 in 3 chance of guessing.
And then I'll give you
No points.
1/2 points or none.
Nice.
Well, then you just gotta guess a 1 in 7 of which test to use, and then you have a, you know.
Okay, as I just said, in the factorial, you have to use a comparison test if you actually need to figure it out. Determine convergence.
Since you it's less than well, you said less than the 1 over n squared.
No, 1 over n squared is bigger.
You guys going absolute value first, or are you going,
Absolute value.
Absolute
Yeah.
value. How do you do direct squares?
You could just do what Weaves does and test out a system with you.
And plus 1 is, no, it's
It's less
bigger.
than.
And plus 1 is bigger. So with the bigger series to convert.
It's bigger.
That converges by P-series test. Yes!
Wait,
no, you can't do P-series.
What? It should be direct.
You cannot do P-series.
You can't do a
Not with factorial. P-series, you need to have something over n to a P alone. Maybe you can have like times a C, but there can't be any addition or subtraction whatsoever.
Can we do the nth term test?
Nope, because n approaching is 0, we know nothing.
Yeah.
Well, we know this conditionally converges, but we don't know absolute until we test the other.
Wait, what if you direct comparison?
You could do direct.
You do both.
I
Just limit me.
I'm showing you the limit one, because the direct we have to figure out greater than less than, which should be pretty easy technically, but compared to, I would say, 1 over n squared.
Yeah. Less than.
Why would you compare to that?
Because 1 over n is divergent.
We know that's by not geoseries, by p series p equals 2, right?
Yeah. Then that-
So compared to the convergent series 1 over n squared, which would lead us to the limit as n goes to infinity of n squared all over, who's always going to win with a factorial? The factorial. Why did I choose a convergent? Because if this guy's always going to win, the limit's always going to be 0, and I can tell something for the limit comparison test if I have a convergent whose limit is 0. If I'm comparing to a convergent, and the limit is 0. So I can say,
Absolutely.
then, the series converges absolutely.
Why did you have to do a limit?
You could have done a direct comparison, you could have compared to 1 over n squared, which would have been greater than, since this guy's denominator is stronger and hence the whole thing is smaller. I just, in my head, that takes more mental work than just multiplying by n squared, aka dividing by 1 over n squared and seeing the limit is 0. That's just me. But if you had done direct comparison, 1 over n squared would have been greater in converging. Bigger in converging would have squished it in. So that works too.
But if you know 1 over n squared converges, doesn't that just mean you're done?
Only if, well, okay.
I thought
What if-
I heard you get checked for conditional.
need to test the absolute value of the function at some point to figure out conditional or absolute. Reason being is because the limit as n goes to infinity of this term is equal to 0 and the terms decrease. So notice this is at least conditionally convergent. To test for absolute, we check the absolute value. When we look at the absolute value, we ignore the conditional, the negative 1 to the n. We have 1 over 2n plus 1 to the factorial. I have no way of saying whether that's convergent or divergent because I cannot do the nth term test alone, because if I just do the limit as n goes to infinity, hey, it's 0, I know nothing. So I can't use that one. I do a comparison test because factorial, I have no way of integrating or anything else. It's not geometric, it's not a p-series. You could have done direct comparison and compared with 1 over n squared, which is going to be greater than because his denominator is smaller, which is convergent. But I could have also compared to 1 over n or 1 over square root of n, and all of them are going to be bigger. The problem is I don't want a divergent bigger, I want a convergent bigger. Or the limit comparison test, I could have compared to 1 over n squared. When I multiply, the limit will always be 0. I could have compared to 1 over n, but when the limit is 0, the divergent would have told me no.
I understand what you're saying.
Does that make sense?
Yeah.
Okay. Whew. With all of that. Okay, kiddos, this homework is due tomorrow, yeah? We have not done the evens, but to be honest, from section 9.4, we don't have time anyway. Tomorrow, listen, shh. This homework is due tomorrow. As soon as you come in and break is over, aka nutrition is over, I want you guys in your groups. When I say, okay, check, what I mean is 9.4, 9.5, check the evens in your groups, talk out questions. Does that make sense? Let's figure out where we have discrepancies, where we have disagreements or confusion, and let's try to address it. Sound good? 9.4, 9.5, spot check tomorrow, aka have it ready to go, because your group needs you to collaborate. Hopefully you were listening, or else it might be a bummer if you're not ready.
Spot check.
Hey guys, look up here! Didn't we just say we had no other way to deal with factorials at this point without a comparison test?
Yes.
What's so nasty about numbers 1 and 3?
It's on top and bottom.
They don't just have factorials in one place, they're in two. So how do we compare?
Take out both.
Don't stress, there's a nice test for any factorial that you will ever see, and it's about to come in section 9.6. But in order to do said test, we have to be able to look at number 1 and say, oh, no big deal, this ends up just being
K plus 1. So
k plus 1. Or looking at this one and saying, oh, this just ends up being
N plus
2n plus 1 times 2n plus 2. Uh-oh, do you need to review factorials a little bit?
Wait, are those factorial rules?
Kind of. Alright, okay, finish 9.5, have 9.4 ready, and we'll go over questions tomorrow. Bye.
Ready for Mr. Mills.
If there are any problems about other handouts, skip them, we'll talk about them together.